Hi everyone, how are you guys doing? Sorry I haven't been streaming for a while. Um, Life is busy. Life is very busy. Um, so I'm gonna continue this series, the regular, SFML series. Today I want to do something different. Today this is just for my own kind of studying, nothing more really. Um, I might even delete the stream at some point. I'm not sure, but this is not going to be a teaching stream. This is going to be mainly me trying to figure out how to create a rasterizer. I watched a few videos beforehand, and it seems really interesting, and I kind of want to try it and see if I can make it work. Um, so the way I think I'm gonna go about this is by just rendering things. Obviously, it's going to be on the CPU. It's not going to be any GPU involved. I'm not going to use any libraries. I think I'm going to go ahead and do the Windows API. Maybe. Maybe SFML. I need something to output pixels. That's kind of my goal. I just want some pixels out on the screen. I think the Windows API is fine. I don't know. It's going to be an exploration stream. Really. It might be a bit boring. Apologize about that if it is boring. But I kind of want to learn that and kind of explore it and see how it goes. All right. So I guess. Hey Kareem, how are you? Software rendering, yeah. So I don't know. Today I was watching a video about rasterization, and I thought, hey, that's pretty cool. I think I can do this on my own. So I kind of want to explore it. Yeah, just try it out and see how it is, just for fun. Kareem, I've saw a bunch of your comments. Honestly, haven't had the time to reply. I will reply to you. I apologize for that. But yeah, I think our next stream for SFML is going to be memory management. So I know, Kareem, you've been wanting to do the kind of memory management and asset management. So I'll do that next stream. I'll try to do it as soon as humanly possible. But yeah, today I just want to do something fun, no teaching, something a bit, advanced, I suppose. Okay, so the first thing I want to know and figure out is how do I really, output a bunch of pixels on the screen using Windows API. This is also going to be in C++, so I don't know. Let's see. Windows output pixels on screen, Windows API. Let's see how this is done. Let's hope it's not too difficult. Oh, that's not very helpful, Microsoft. So get device cap. So yeah, as I said, the stream is just gonna be me really reading a bunch of documentations. It might be a tad too boring, but let's see. Again, it might not be up. I might just remove it and delete it. Okay, so he's creating a Windows. I'm kind of familiar with how the window thing is created in Windows. How do you create Windows? I just want to know how do you output pixels on the screen. So he's doing paint, get client rect, select object, white brush. This is what is this? Select object and paint. Oh, here's where he's painting. Isn't that the same thing as here? Yeah, it's the same thing. So W paint. Just want an array of pixels to paint on the screen. Honestly, we might even not do that. Maybe that's a bit too much, too complicated for what I want to do. Fuck this. Sorry, I'm gonna try to keep this PG 15, 13. simplest image file formats. BMP. You should typically avoid using BMP file for I don't care about really content. Okay. Let's see. Writing to a BMP or creating a BMP file. Let's see how this works. I think it's just an array of pixels and you just save it to a file. BMP file format. I think a Wikipedia article should have everything I need. Here we go. This is what I need. Oh, really? Okay. Why are you mad? Why are you mad, bro? Don't be mad. What? Why? Just wanna... Whatever. Alright, so the BMP file header, signature, dip header, header size, image width and height. That's a lot of information. I don't care about compression. There we go. Just want the simple. Okay, example one. Following example of 24 bits, RGB 24. So the first 2 bytes is BM. The next 4 bytes, size of the BM file. These are unused. Offsets where pixel array can be found. This is the BMP header, and then there's the dip header. Number of bytes in the dip header from this point. Width of the height, number of count being used, number of bits per pixels. These are the values that you have here. Example 2, this is a 4x2 32 bits. Whoa, this is quite the thing. So there's a difference here where the size of the file obviously changes. I tried this before with great book Trick of 3D Programming Guru by Andrew Lemon. I love this book so much. I learned game from scratch with the book, but it was really slow render. Now I'm working on a 2D physics and facing problems like stability and lack of resources. Try this for. I've never tried to. First of all, let me check out this book. Living Guru by Andrew Lemon. I've never tried making a physics engine. No. Like the simplest physics engine that I made. Oh, looks cool. Oh yeah, oh no, that's this is the book you're talking about. So I guess you could call it a physics engine, but it's very simple. Like as far the furthest that I've gone was to make two bounding boxes and a circle and having collision between them, and if one collides with the other one, you cannot go through the bounding box. That's as far as I got. I didn't really, and you had velocity, acceleration, but I didn't really go beyond that. I didn't do like rotation stuff and so on and so forth. Physics really doesn't interest me that much. Really more interesting in the rendering part of things, the more programming part of, I don't know, rendering. But yeah. I'll check this book out. Oh, that's cool. Can I see it? No? All right. I'll definitely check it out. Thank you for that. Offset where the pixel array can be found. He's saying 122 bytes. Why is it 122 bytes? 14 plus 104. Oh, so the 14 is 2, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this is 14 plus 108. Number of bytes in the header. Oh, this is the 108, right? So he's basically this value here, the AH value, I suppose, is the size of the BMP header and the dip header. And this is where you have your pixels starting. Okay, that makes sense. Okay, so I understand this part. So this is how big the dip header is. That's understandable. The width and height of the thing. That's also understandable. Number of color palettes being used. One plane. So what? You just pass in the number one? Oh, you do. Just one. Okay. Number of bits per pixels, 32 bits. Okay. No pixel array compression used. Number 3. Size of the row bit data including padding, 32. I don't understand this. Why is it 32? Print resolution, understandable. Print resolution of the image onto DPI multiplied by the inch yield 2835. That's 2835 in hexadecimal. Hex to decimal. It's the other way around, I think. There you go. Goes big Indian, small Indian, and all that bullshit. Whether it's just big Indian or little Indian, I don't know. You must go through this book. I can send you, but the problem is that I take which is actually draw. Oh, I see. I mean, it's fine. The knowledge really doesn't change much, or at least the basics doesn't change. I can. No, it sounds like a great book. I'll definitely check it out. Yeah, the tech is different, but you know, you can do other things: direct draw, accelerated pixel rendering. Yeah. So today my morning started with playing a game of League, which has been a cancer that has been taking over my life for the second time after I quit a long time ago. Figuring out that I'm 30 years old right now, and I need to take care of myself. Went to the gym, ran for about 45 minutes. No, that's a lie. 49 minutes. Got really tired. Got back home, showered. While in the gym, I was watching on my tablet tile rendering. So I remembered the conversation between me and a colleague where he interviewed for Intel, and they asked him about tile-based rendering for GPUs, and he was saying something along the lines of the amount of questions that Intel asked him were so not so difficult, but like they asked him questions, they made him feel like he's the dumbest person on earth, that he doesn't know anything, right? So I was like, okay, that's pretty cool. I mean, let's look into this. So I looked into tile-based rendering, and from there looked at rasterization. From there, I was like, huh, this is not too hard. I can do this, and here we are. So yeah. All right, where's this? Oh, it does say big Indian. Red color bit mask valid because bit field is specified. Okay, and then a bunch of these. Oh, this is if I want, okay, so this is if I want an alpha channel, right? 32 bits RGBA. I don't care about A, and it's ARGB. I hate this format. ARGB. Like, why? Why not just RGBA? Like, it makes more sense. I don't need 32 bits. I don't care about 32 bits. 24 bits is more than enough. And this will be RGB. There you go. This is what I want. Much, much smaller, much simpler, without this complexity over here with, I don't know what bin this is. I don't want to. Okay, we're implementing this. All right, let's do it. This looks easy. It's not that difficult. Easy enough. All right, we're gonna create a brand new project. I'm gonna call it rasterizer. This is going to be in C++. Empty brand new project. How do you spell? You know what? I'm trying to swear less and less because I feel like I've been swearing a lot, and it's just not good. Just not good for you. Okay, gotta improve your vocabulary. Be a little bit nicer. And I named it capital, rasterizer capital. I like to name my project small letters, not capital letters. So I'm gonna go ahead and delete this project and redo it again. I'd like to go to my, oh guys, you wouldn't believe what happened to me the other day. Was it here? Here, yeah. Goodbye. We'll see you. So you don't believe what happened to me the other day. What? No, I don't want this. I was working on a project for my full-time job, right? And rasterizer small r, thank you. And there was a bug, right? I was trying to do a port number. Like I was trying to build this Docker container. If you don't know what a Docker container, just essentially just a package that has a bunch of Node.js code, or it can have really any kind of code. But for me specifically, I was using TypeScript, and I had an application. Docker essentially allows you to package an application and release it on the web in one image, one file, right? And so this would be me. And so I was building this Docker file and I was telling it, hey, I would like to listen to a port number, specific port number. Again, if you don't know what a port number is, fine. You know what? I'm going to act this as the stream. You guys understand what I'm saying. So I'm going to gloss over teaching stuff. So I was trying to build this Docker image on a specific port number. The port number was like 6007 or something along these lines. And every time I build it, and I deploy it, it would listen to port 8020. 8020. But I built it. I specifically told it to listen to this port number. It was the weirdest thing in the world. And after hours and hours of debugging, this is what I found out. If I change the package name, if I change my software name, right? For example, the software name I called it rasterizer. If I change it to something else, or if I add even just a letter after it, it would work. I would get port 6007. If I put it back to the old name, it would give me 8020. If I change, I think I called it dev port, so I did dev port equal 8080 or something like that. Oh no, 600. I did that, right? If I call it dev port X or dev port A or literally any name, or even development port, it would give me 6007. If I go back to dev port, it gives me 8020. And I thought it's like a caching issue, right? It's being cached, and this is like, it's using some cached value in Node.js. I went ahead and deleted all the cache, nothing. I installed Node.js altogether, nothing, same issue. I reinstalled it, still same problem. And I tried to delete some more cache stuff, and by mistake, I deleted my entire, where is it? I was in the app data, I was in local, and I wanted to delete the temp folder, right? I wanted to delete this temp folder. And by mistake, I deleted all of this. And I had to reformat my entire computer. And that's why you see Windows 11 here. it's a bug that caused me to wipe out my PC, which was absolutely beautiful. And I still don't know why that bug happened. And it fixed after I reinstalled Windows. It's fixed. So it's a caching thing, but I don't know where it was being cached. It is so stupid. I wasted 11 hours just reinstalling everything. That was so frustrating. I was gonna cry that day. I was like, please, please, why? Oh no, I want that book. I would like to pin this, please. Thank you. And I would like to also pin this. And I'd like to also pin this. And the others can go away. All right. So I want to start by C++ write file. I always forget how to write files. So God bless the documentation. So include iostream, include fstream, of file, of stream, std. Whoops, don't do that. Of stream. Let's do this. Of stream file dot open. I'm gonna call it image.bmp. Okay. It's gonna be file and just, you know, data, and then be file.close. Okay, so let's build this data structure. The first thing I need to do is build the BMP header. So I'm gonna make a struct called BMP header. This struct will contain a few pieces of information. The first thing it's going to include is the ID, which is always going to be an std string. It will always have the value bm. Okay. Next, we want the size of the BMP file. So this is going to be an int. Should I? No, you int. Should it be an int? I mean, what is it? It's a 4 byte. Okay, so I need to make sure I follow these. So size is 2 bytes, right? Actually, it's going to be a char string, char array, const char array. This is 4 bytes, so this is going to be an int 32t. This is going to have the value of this is going to be size called bmp header size. Actually, I'm just gonna no, let's do this. Okay, and then unused and used, so 2 bytes here. So let's make a int 32 16 and 16, right? Because it's 2 bytes, 2 bytes. This is going to be called unused or padding. Oh, I can't have padding twice. So what I could do is I could do an int 32 padding. No, I'd like to stick to this. Just, you know, unused 1 and unused 2. Yeah, that's fine. Offset where the pixels can be found, and this is the this will be an int 32 underscore t. This will be offset to pixel data. Okay, this might be BMP header. Okay, so we're gonna make another struct The second struct is going to be our, I don't know, you guys can see this. Hope you can. It's going to be my dip header, right? So this will be dip header. Dip header is gonna be number of bytes in the dip header. That's 40. This is 4 bytes. So dip header size. And then we're gonna have the width. So width of the bitmap in pixels. And he put the value of 2. Okay. That's 4 bytes. So width called image width. And we're gonna have, whoops, don't do that, buddy. It's gonna be our height. Beautiful. Okay. This is going to be 2 bytes, number of color planes being used. Okay, I'm going to call it color planes. It'll be 16-bit. Number of bits per pixels, bits per pixel. And then this is no pixel array compression. So pixel compression. And then we have our print resolution, width and height. We're gonna go with horizontal print. I can't spell resolution, so I'm just gonna copy the name resolution. It's gonna be a 32-bit value because it says 4 bytes over here. It's gonna be our vertical print resolution. Number of colors in the palette, 0. Okay. This is 4 bytes. Colors per palette. And finally, 0 means all colors are imported. 0 imported important color. Important colors, I guess. What? I don't even know. And here we'll start our pixel data. Okay. And then we need another struct. Pixel data. We'll have 3 bytes. What? How can we have 3 bytes? 1 byte, 2 bytes, 3 bytes. What? How do you expect me to do 3 bytes? Excuse me? Red. First pixel is 3 bytes. Here it's 4. 4 because there are 4 8 bits. Really? You want to do 3 byte? Okay. I mean, I guess. Okay. Okay, before that, I need to make a struct called pixel. This lovely pixel is going to have uint 8 t red. Do I call it red or R? Just do R, because RG, whoops, don't do that. RG, RGB. Okay, it's red, RGB. What's the file format? It is RGB. Okay, cool. So RGB, and then second pixel, and there's padding. Padding for 4-byte alignment could have value other than 0. Padding for 4-byte alignment. How could it be 4-byte alignment when it's 2 bytes? Then he does another 2 pixels, another 2 bytes padding. Okay. So this is going to be, it's going to be a pixel. Pixel. This is the first pixel. And then is the padding. The padding is 2 bytes. So we're going to do no, this is going to be 1 row, right? So this will be like a row of pixels. And then there's the padding. And then another row of pixels. And then there's padding. Okay. This will be a pointer. Not gonna use any complex data structures. I'm gonna just stick with, it's more gonna be like a C program actually. It's gonna be a pointer pixel to a row of pixels. And then pixels data. And then the padding, which is 2 bytes. So a int 16 t padding. Okay. And in the end, we're gonna have a struct called BMP image, which will have all these lovely structs. It's gonna have a pixel. Nope, sorry. Gonna have the BMP header, BMP header. We're going to have our lovely dip header, and our pixels data. Whoops. Pixels data. Okay. This is going to be 1 row. Right, so we might have more than 1 row, so this will be also a pointer. It's gonna have multiple rows. Okay, I have no idea if this will work or not. Let's try and make it work. Okay, so we'll start with creating a BMP image, BMP. BMP dot. We'll start with the BMP header with the ID equal BM. I think this will be private because, you know, we already know what it is, right? Honestly, like these I could just set them from now. No? Yeah, I could set them. Like BMP header was going to be equal to size of BMP header. These are unused. Offset to pixel data is, we know the offset is size of BMP header plus size of the dip header, right? So this is data that I already know. Why you're not happy? Initialized. This will be equal to 0. This will be equal to 0. Okay. 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 This is good. This is very good. Can you update? Are you not gonna? Okay, you know what? Whatever. Okay, so this is my BMP. So this could just all be private, really. Actually, no, let's make them public. This will be keep as is. I don't need to deal with the header. Okay, dip size is, size of dip size. Image width is by default 0. Image height by default, all this is just 0. Okay. 0, 0, 0. 0, speed, null, tr. And okay. So I don't need to deal with the header, I need to deal with the dip header. Let's do that. Okay, what do you have for the dip header? We need to initialize the image width. Let's make it 4 by 3 pixels. 4 by 3. Let's do 4 by 2. 4 by 2, okay. I need color planes, and I believe the color planes is 1. I have a hard-coded value of 1. This will always be 24 bits. This is 0. Size of the row bit data, including padding. Size of the raw bitmap data. 16 bytes. Why is it 16? I don't know. It's hard code these values, really. And 0, 0. So really, the only thing we need to specify is these, right? So what I could do this. With height. Image width. Image height. I like to use this format. So image width is image width. Image height is image height. I can make all this private. I can make all this as private. I'm thinking. I am thinking, should I do it this way or not? It's fine, I think. But no, I need to write this data later, so they cannot be private. They cannot be private. So, yeah, never mind. Okay, whatever. So these are the only two things that we really need to specify. Honestly, this is the only thing we need to specify. So this is going to be BMP header. Nope. Image width, image height. It's going to be a int int 32 t int 32 t dot image width equal image width. Image height is image height, and pixel data will be a pointer to pixel data. That's pixel data. Oops. Okay. Yeah, so I don't need to do this. be 4 and 2, and we need to specify the pixel data. All right, so the pixel data will look something along these lines. This will be okay. There's all of my stuff over here. Okay. Yeah, okay. So pixel data now. Pixel data is going to be, since we have a 4, it's a pointer, right? So how many rows we have? We have 2 rows. So pixel 2 rows. Oh no, I can't specify pixel data here. Okay, it's gonna be equal to a new pixel data of 2 rows. Okay. Pixel data at index 0. And okay, so hold on. So this is pixel data. Inside pixel data, there's row of pixels array. Okay. Okay. Dot row of pixels equal to a new pixel data. How many pixels we have? We need a new pixel. 2 pixels. Pixel 0 will have the color. This is a horrible way of doing this, so I'm gonna figure out a better way to do this, but for now it's fine. I just want to test if this works. It's going to be an RGBA value. So the values are 0000FF. Oh, dot R equal 255 RGB 00. Okay, that's the first pixel, and this is the second pixel. It's gonna be 255. How many pixels? We said in one row, 4 pixels. So we need 4 of these guys. Again, this is just for testing for now. We'll clean this up later. Okay, so this is RGB, green, and then let's do white. So red, green, blue, white. Okay. And we're gonna copy this. Let's do that. We're gonna copy this and paste it. All of these. This is the second row of pixels. And the second row of pixels is gonna be reversed. Will be white, 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 and then blue, green, and then red. Okay, and then I pass the pixel data. Okay, again, this is just for testing purposes, guys. Calm down. Okay, I know the code is disgusting. You don't have to yell. I can hear you yelling. Stop it. Okay. So, I would like to write I want to specifically say this is a binary file, but it's fine. I think. Okay, let's try some stuff. So these are the first things that I write, right? So I'm gonna write BMP. Let me put this full screen. BMP dot BMP header dot ID. That's the first thing we write. All right, so we need it in this order. Do that, do that, do that, and do that. All right, first one, second one. Take this. We're gonna do, this will be dip header, image width, image height, oops. Image height, image width, color palette, bits per pixel. Oops. Bits per pixel, pixel compression, horizontal print resolution, horizontal vertical resolution. Do that. What? Horizontal. Okay. And then we need to write the actual data, which is bits per whatever. Okay. So now, okay, this will be 4 pixels, another 4 pixels, padding, and then padding. Okay. Pixel data at index 0 dot row of pixels at index 0 dot r. Fuck. RGB. Simply 1. So this is the dumb way of doing this. God, why did I do this? I should have stopped. Don't worry, guys. It's fine. It's fine. It'll be fine. And then don't forget the padding. So here's the padding. Dot padding. Okay. Then we copy this again for the second row of pixels. Oh shit, I don't know which one is which. Okay, the second row of pixels would be over here. These are ones. Okay. In theory, and this is just a theory, if I run my application, it's gonna create an image file. Okay. Now, this could obviously not work, so let's see. If it works on the first try, what is, oh, this is a header file. What? Why is that header file? CPP. Change that to a C++, please. All right, let's put this. Dip. Dip. Oh, yeah. Of course you can't find it because it's under it. Out of I mean, I could just put this up. I want it to be in this order. Out of curiosity, can I just... No, I don't think I can. And I can just put you down there. Okay. Whoa. Okay, something is null. At least this is not null, so I'm happy about that. Did I not make? Oh, I did not do it. Okay. So we did it for the first one. Didn't do it for the second one. Okay. What's your issue? Buffer overrun while writing to pixel data 0. How is it buffer overrun? Oh, it's supposed to be. Wait, no, that's not true. Row of pixels is 4. Stupid. Just 2 and 4. So I need 2 rows and 4 pixels per row. There you go. Thank you, Visual Studio, for letting me know. You're so nice. Alright, so throw the file. Dear God, please, if this actually works on the first try, I'm going to be actually surprised with myself. Of course it didn't work. I mean, of course it didn't work. Why would it work? Okay. Let's put this in here. Oh, this doesn't look right. Oh. I'll tell you that. This definitely does not look right. Okay. Well, that was hopeful. Is there anything else? Do we end the file with? Do we close the file with anything? No. All right. You can deal with 1D array as 2D array using. Yeah, I know. But I'm just trying to do it the dumbest way humanly possible and the easiest way humanly possible to just make it work. So here's my first assumption. I think it's writing a text file, not a binary file. So I need to specify, I think I need to tell C++ that this is supposed to be a binary file. So let's do that first. ISO binary. All output operation are performed at the end of the file, appending the contents of the current content of the file. Out opens the output operation. I don't think I want app. So I'm just gonna say this. I don't want app, please. What is ISO? What in God's green earth is ISO? Is it std.iso? Oh, it is. Okay. Alright, let's try this. Will this work? Doesn't look like it worked. Same size. Is it binary? Yes. Oh, nothing changed. Same thing. Okay. That's cool. So what I want to do now, since I don't know what's quite going on, I'm gonna get a hex editor. My favorite hex editor of all the hex editors. We are in Windows 10. Thank you very much. Let's do that. I would like the English version if that's possible. English. Thank you kindly. I'd like to extract this if possible. Thank you. Thank you very much. Open this up. Create a, sure, let's do that. Why not? I don't care about the README file. All right, let's open this image in here and see what is going on, because let me tell you, this does not look right at all. This is going to be a hex, sure, 16, I mean, let's see, 8, let's do, okay. 0, 0 has all these numbers, which is wrong. Nope, sorry, 0, 0 has 32. Why does 0, 0 have 32? How does it have 32? Is BM 32? Does it say BM? BM. That can't be correct. Let's see, hex. These don't really matter. It should have said BM over here, but instead it's saying 24. Not what I intended to have, really. Header size. I didn't put the... I didn't... Did I not write this part? ID, BMP header size. Oh, I didn't write the ID. I'm stupid. Why didn't you tell me I'm stupid? God, you guys. Okay. So now it says BMP. There we go. Does that make any difference? Nope. Still bad. Okay, at least we got the first one correct. BMP then says 24. Okay. So 24. What is the next thing? This is the BMP header size. Is it correct to be 24? Let's check documentation. What has thy documentation said? Nope. Documentation said 754 plus 16. Size BMP file 54 header plus 16 data. Oh, I'm calculating this wrong. 54 plus 16. 4, 8. This is 6, 7, 8, 9, 10, 11, 12, 13, 14. This is 14. 14. Where did the 16 come from? 4, 8, 9, 10, 11, 12, 13, 14. Yeah, it is 14. Where did 16 come from? Size of BMP file. 4 plus 4 plus 4 plus 2 plus 2 plus 4 plus 4. 1, 2, 3, 4 plus 1, 2, 3, 4. Let's get to about 40. 40 plus 16 is 56. Okay, so this is the first header. And these are 16 bytes. 3 plus 3 plus 2 plus 3 plus 3. Whoops. 3 plus 3 plus 2 plus 3 plus 3 plus 2. That gives you 16. Okay, supposed to be 54 plus 16. So it'll be the size of all of this plus the size of this. Okay, so meaning I cannot do this. Okay, so this is wrong. So it'll be plus the dip header. This is the header size. Size of the BMP file. BMP header. BMP header size. I named it correctly. This is the size of the BMP file. BMP file size. I'm stupid. Plus, well, I can't get the size of this really, because this data is. Alright, we can initialize this with 0. And this is 54. This is correct. So BMP file size. BMP file size. Dot BMP header dot BMP file size equal to size of the dip header. Oops. Yeah, give me these, please. Size of the header plus size of pixel bmp dot pixel data. Okay, if I put a breakpoint here, that should be 70. Let's use the same exact example. What is this? 68. And he said he used a 2x2 pixel. Let's use the same exact example. He said a 2x2 pixel. So we're gonna do only 2 and only 2, and then the padding. And so only 2 and only 2, 2x2. So what is the value of that? Value of that is 68, and that's wrong, because in here he says 70. 68. Okay. So let's check the size of these two. Where are the sizes of these two? Size of these two is 60. Is that correct? Does it say 60? Nope, should be 54. Okay, so I know why that is. Because Windows has padding stuff. Turn off padding on struct Windows C++. All right, so we need to turn off padding. Attribute, and just so you can use in here. Push one pops here. Push one pushes the current packing mode internally and sets it to 1. No padding. This shows appears. Okay, let's do push 1. So we're going to do push 1. Okay. And then pop at the very end here. Okay, that should give me now 54. Okay, that give me 62. Is it 62? No, 54. How in God's green earth is it 62? Okay. Oh, why is this there? Go away. Okay, should be 54. There we go. There you go. 54. That's correct. Okay. So I got those correctly. I just need the 16. 54 plus this. That's giving me 62. 54 minus 62. That's giving me 8 bytes. I'm only doing half of the pixels. Why? I didn't say 2. Oops, it's supposed to be 2 anyways. 2, 2. So I'm saying size of pixel data. Size of pixel data. It's a pointer. This is wrong. This is a pointer. Size of pixel data. This gives me always 8. It's a pointer. You cannot do this on a pointer. This is going to be different. This is going to be the value of this. You know what? I'm gonna put a helper function. Inline int 32_t get data pixel data size. This will return this is a pointer. So I know how many pixels I have. I know my pixels is the header. I know the width. You take the width, you take the height, right? The width and height, 2 by 2, multiplied by 3. Because RGBA and each one of these guys is 8. Multiplied by 8. Or size of int 8 _ t. Let's do this math in my head. Have 2 pixels, 2 by 2 by 3 by 8. This is so wrong. 2 by 2 by 8. That's 32. How is it 16? 3, 3, and the padding. Oh, each one is 1 byte. Yeah, so number of pixels, the width and height, right? This is the width and height. No, how many pixels do I have? Image width, yes, image width and height. This gives me 2 by 2 is 4. 4, right? 4. And each one of this 1, 2, 3, 4. Yeah, that's correct. 4. 4 by 3. No, it should be 3, 3. Yeah, 9. 3 plus 3 plus 3 plus 3. Yeah, that's correct. That's 12. And the padding. That's it. What's the padding? So by size of... What is size of... This should give me... Let's give me the size in... This should give me 1. Right? This should give me a 1. Okay. So bmp.get... This should return 1. So this should be 12 right now. Nope, it's 4. 2 by 2. I mean, yeah, 2 by 2 is 4. 4 multiplied by 1. So this is really useless. 2 by 2 by 3. 3 because we have 3 channels. Okay. Get we're just gonna hard code this, and I don't like hard coding things. Okay, multiply by 3. That should be that. That should give me 16. Oh, that gives me 12. I forgot about the padding. Plus the pattern dot plus pixel data dot padding two by 2. For every 2 I need 1 padding. For every 2 I need 1 padding. For every 2 I need 1 padding. It gives me 4 multiplied by sort of padding. I can't add plus height to this. Okay, the width and the height, figure out how much I need padding, and you end that by multiplying everything by 3. That's wrong. No, it's correct. Oh, look at me. Not all stupid. Not an idiot, total idiot. Okay, let's write the file. What do I get? I get, can I get decimal? Octa, nope, that's just this. Okay. I get BMP 16. BMP 16. What? 16. So, hold on. The first thing I read, BMP file size. Am I writing the file size? Yeah. That's the second thing I read. 16 BMP, and then I use 0, 0, and then 54. So okay, so BMP, yeah, 16, correct. 0, 0, 54. That's all correct. Okay. So far, so good. Do we have anything on the image? Nope. Because why would I? Okay, that's correct so far. 54. So all this is correct. Next. Dip header size is 34. Is it 34? No, it's 40. Why does it say 34? 34. I bet you guys can't see this. I'm sorry if I can't see this. I don't know. I don't think I can make this sound larger. Can I make this sound larger? Format, view. No. Format. Can I change the size? Oh, choose font. Oh, here you go. Can I make it like 48 so you guys can see? Oh, there we go. There we go. Oh, you guys can see. You guys can see way too much. I think we should drop it down slightly to 36. Nope, still way too big. Let's do 26. Nope, still too big. Jesus. Let's do 24. 24 works. Okay, 24. Still too big, but that's fine. It's fine. We're gonna do this at 8. Thank you very much. Okay. So BMP 16 00 54, that's all correct. This is supposed to be 40, not 34. So let's see what's going on in here in the dip header size. The dip header size says 34, and the documentation says 40. Number of bytes in the dip header from this point, 40. Why is it 40? Because 4. Because if you add all these numbers, you get 40. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 by 4 plus 2 plus 2, you get 40. Okay, so let's see why am I not getting 40? Where's the dip? So dip header size. So I specifically told it 32, 32, 32, 16, 16. Aha. That's why. So, whoa, calm down. Calm down. I need you to breathe and calm down. Thank you. Okay. So this would be gonna be 40. Nope, still 36. Still 36. I mean, it was 32, now it's 36. I think it was 32, wasn't it? So, can't see what's wrong. 4, 4, 4, 2, 2, then 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Whoa, I'm missing something. What am I missing? What am I missing? Okay. See. Can you just, yeah, thank you. Thank you very much. Okay, dip header, pixel width and height, the plane, bits per pixel, pixel compression, this size of raw bitmap data including padding. Forgetting this, it's gonna be 32 bits. Size of raw bitmap data with padding equals 16. Now, the reason it's 16 is because this is 16. I imagine if this changes, right, if this will change. Size of the raw bitmap data including padding. Yeah, so this 32, 32, this 3, 3, 2, 3, 3, 3, 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I cannot hard code the value 16 in here. So what I need to do is do this. Just like how I do it here. Okay. So BMP, nope, this will be dip header. Dot size will be get pixel data size. Why is it repeated twice? Oh no. Yeah, why is it repeated? 16 over here. And BMP file size. Wait, BMP file size. Well, these are different. Hold on. How am I saying file size is 16? Is it 16? What am I saying here? It is 16. How am I saying 16? It's not 16. The file size is 54 plus 16. Okay, so we're missing a few things here. There'll be a size of... We need these two. Or I could just do BMP header offset to pixel data. Or I could just do this. Just do this. There we go. Okay. So this should be 70. 70. Well, it's 76. Why is it 76? And this is 16. This is 16, correct? Why is this 76? It's supposed to be 70. God, why are you so annoying? Okay, let's see what the size here. Dip header should be 40. That's correct. And this should be 4, 5, 6. This would be 12. 4, 8, 9, 10, 11, 12, 13, 14. This should be 14. It says 16. Oh no, 14. 14 plus 40 is 54. Yeah, this should be 14. Is it 14? It's 20. Why in God's green earth are you 20? BMP header. BMP header. Why are you 20? We have a lovely 2, then a 4, and then a 2, and a 2, and a 4. How are you... Excuse-moi, senor. Is this not 2 bytes? Just... Wait. Okay, hold on. What's the size of ID? ID should be 2 bytes. If it's not 2 bytes, I'm gonna be upset over here. It's 8? How are you 8, bro? You know what? This is my fault for using char anyways. Const There should be 2 bytes. Const int 8 underscore t pointer. It's my fault for assuming. I'm stupid for assuming. What's wrong with you? Cannot convert const char. Oh, brother. It's 3. Oh, the null terminator. The null terminator. It's 3. Why? Wait, what? Cannot convert const char 3 to constant int 8. Why? BMP cannot be initialized. Why are you? I understand you're not happy. But later on, can I make you happy later on? Can I make you happy later on? Like, do this? You're obviously not gonna be happy. Obviously. Yeah, it's the same error. Const. Const. Does that make you happy? It does make it happy. Okay, what are you? What size are you? 8! How? How is it 8? I specifically said it's a pointer. God, I am so stupid. I keep forgetting this is a pointer. Okay. Please, please, I am dumb as freaking heck. Stupidity is just reaching a new high level. New level of stupidity, swear to God. I cannot do size of ID. Size of BMP header. I cannot do size of BMP header. Because this is a pointer, and because it's a pointer. Oh. I wonder. Can I just say char? Okay, hold on. Char ID. Okay, can I just do this? ID, and it's an array of 2. Let's say 0 is equal to B, and 1 is M. And just be done with this. What's your problem? You're fine. Will you build? God, I hate you. And now it's 2 bytes. It's 14. It's 14. Yeah, it's correct. Ah, pain. We're not using const. I'm gonna use uint 8 underscore t. Okay. All right. So this works. Oh, BM. Okay. Pointers are annoying, bro. Don't call me bro, I'm not your bro. Okay, this should work now. Hold on. I forgot something. So this is the BMP file size. This is BMP header plus that plus this BMP header plus the dip header. So now this is going to be 70. Yeah, there we go, finally. And this will be 16, correct. Beautiful. Absolutely wonderful. All right, let's see. BM, this is F7, 70, 000, 53. Okay. Oh no, it's 54. God, what am I? I'm stupid. Okay. This is 0, 4, 4, 35. So that's 53 though. Wait. Wait. What? 54. Is this like, this is supposed to be hexadecimal, right? This is text decoder. $52. What? 70. What is the F is? What's the F for? F? It's 2 bytes. 1 byte, 2 bytes. And then another 2 byte F7. Is F7 70? No, F7 is not 70. Wait, what? What's F7? What? Okay. BMF7? What? Why is it F7? I mean, F on its own is 70? No, that's not correct. F is on its own, it's not 70. Bro, what? Blah, 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 blah. I don't care. Okay. What's ID? ID is BM. Next. 70. Next. 0. 0. 54. 70054. Why is my hex editor saying different things? Am I reading this wrong? Am I stupid? I could be stupid. What is F? Where did F come from? This is 2 bytes, meaning we take those 2 bytes. F7. F7 is not hexadecimal basis for internal. F7. Then it says 53. And then there's a 4. Why is there no a 40? I mean, BMF. Okay, this is the 70. Oh my god. This is the 70. This is the first 0. This is the second 0. This is the 54. And this is the 40. Where did F come from? Is it because I am dumb as hell? God, please help my stupidity. It is too much. So fucking stupid. The F was the... Just I don't want to talk about it, okay? I think the F was the null terminator. Okay, BM 70 0054 40. That's correct. What's next? 2 and 2. It's correct. And then the 1. That's correct. 24. Correct. Why is there's a 1 here? It should be 0 here. Should be a 0 there. Why is there a 1? There should be a 0. Then 162 here, 2A35, then 2A35 again. There's a 16 in here. Why is there 16? Should be 0. 4 bytes. Why is there 16? Pixel compression. What? 0. Why did I put 16? Size of bit, yeah, I think I made a mistake. Okay, it's fine. It's 0. Okay, so 40, 54, 40, 42 and 2, 1, 24, 0, 0, 0, and then there's a 16. There should be a 16 after the 0. So there's something I didn't write. Pixel compression. Then size, something, size of, oh, there you go. Okay, run that. Okay, so now it's 0, 16, correct, 2535, 2535, and 2 zeros. And there's my pixel. It should work. Damn you. Okay, so I got it. I mean, so far so good. Can I maybe open it with MS Paint? No. Okay. Okay, so I got all these correct so far. Now the pixels. Now this is 255, correct? 0, 0, and then 0 with 255. Oh no, it should be 0, 0, 255. I mean, it's fine. 255, 0, 0. And then the second pixel would be 0. What are my values? So I did 255, 0, 0. Yeah, that's correct. And then 0, 255, 0. That's correct. The second pixel. Okay. And then there should be padding of... There should be a padding of 0 and 0. Padding for 4 bytes. This is the pad. There's an issue with the padding. It's 4 bytes. Padding. Where's the padding? 16. Does it go like this? Padding 1, 2. What's wrong? Padding 1. Wait, 2. Size of uint 680. Heading 1, heading 2, heading 1, heading 2. To 0, 0, 0 to 0, 0, 0 for a padding, and then damn, it's still not correct. Okay, 0, 0 for padding, and then 0, 0 for padding, and then for my other pixels, and then 255, 255, that's correct. And then 0, 0, 255, that's also correct. And then the padding, 0, 0. That's it. That should work. Why is it not working? I did everything correct. Hello? What? This is 44 bytes. This is all correct. Why is it not working? BM 70 0. Is it supposed to be 0, 0, 0, 0? Because currently there's just 2 zeros. Where in here it says 0, 0, and 0, and 0. It says 30 and 30. This is 70. This is 30 and 30. This should have the value 0. Just like here. This is the padding. Okay. Why can I not use just a single thing? That's interesting. This is here. It's not happy with uint 16. I wonder why. I wonder why. So this would be have an area of 2. An area of 2. And then here's another area of 2. These should be both that. Equal 0. 0, 0, 0. 0, 1, 0. I could just make an area of 1. Make an area of 4. Unused, unused. Should be 0, 1, 2, 3. Will it be happier now? Yeah, it's happier now. Any chance this fixed it? Oh. Okay. BM 70 0, 0, 0, 0. This is supposed to be 36. It says 35. 54. $42 for D. 40 46. This should be 46. I'm doing something wrong. There's the way I'm writing my data is wrong. The way I'm writing my data is wrong. Just simply writing BMP file size. It's not happy with that. BMP file size is supposed to be 70 bytes. 70 bytes is supposed to be 4 bytes long. This is just 1 byte, 2 bytes. It's because of unpacking it. I do too. Nope. I remove this altogether. Port 40. Oh. That just made everything worse. 4. Okay. It's just debugging me. Even if I do release them, it's not gonna matter too much. It's supposed to be 42, 40, 46, 0, 0, 0, 0. But that's not happening. It's over here. It's not happy with it. Okay. If I do int 32, let's int 32c. What if I just use int? I'm curious. What would happen? Wouldn't you give me the same results? Should not change really. What if I run my compile my application 32 bits? More than 64. Oh, same thing. God, I'm starving. Why is it 3730? Then the 2 zeros. It's not. The way I'm writing it to a file is not correct. I'm pretty sure this is not correct. Because if I take this, hold on, I have to back. I'll be back. I need to answer the door. Hello. See? I told you I'm writing it wrong. What's your issue? Once. Okay. See? Now it's correct. I told you I was writing it wrong. God damn it. I have to write. I have to use the right function, otherwise I would have to write byte by byte myself. That's something I completely forgot. It's gonna format it as text, whereas write operated formatted. Um. God damn it! I'm so stupid. I'm so stupid. I'm so stupid. I'm so tired and hungry. I have to rewrite a lot of this code. Oh God, so stupid. So very stupid. Stupidato. Ai ai ai, stupidato. Const char id equal bm, not chat, char, dumbass. And this would be a 16, gonna just do a 32 byte unused equal to 0. God, why am I so stupid? No, you know what? I'm gonna keep it the way it was. Unused 0. Someone please tell me, why am I so stupid? Please. Please. Alright, I don't need this ID anymore. I have the ID. BMP file. Size unused 0, unused 1. Need the size of unused 0, size of unused 1, size of ID, and size of offset, BMP file size, BMP file size is under ID, BMP file size is under ID, BMP file size. Compare data. Why is it? Why? 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 It is char. Can I adjust ID? Because it's already const char, dumbass. Okay, 42D. This should be 64. What's the next thing I'm doing? Map file size. Map file size. It's an N32. Can I just do, I mean, it's gonna do the same thing. 4D supposed to be okay, so this is wrong. But then 00 correct, 00 correct. And then this part is wrong. Can I just comment out this on this? Thank you very much. Okay. Now, why am I not getting the correct values for these 4 bytes? That's really my main question. It's not gonna work. It wants a const char. It wants a const char. Can't give it that. I cannot give it that. It has to be a char memory address of this and the size of BMP file. BMP file is 70 because it's 72. Mother freaking 72 because this is 3 bytes. I can't do this. Need to go back to the array. I hate my life. I hate my life in ways you cannot imagine. You might try to match them. You really might be like, hey, you know what? Your life is not that difficult. Which is true, you know, compared to other people's lives. My life is a breeze. An absolute breeze, but I hate it. Okay, that's a lie. I don't hate my life. I love my life, but you know. Sometimes just things don't work the way they're supposed to work, you know. They just don't want to work the way they're supposed to work. They just don't work the way they are supposed to work. You know why? Because my life's hard. Okay. So, 42. Okay. So, you're gonna do that, huh? This is correct. The ID is not correct. It's PM. What more do you want? 0 and 1. Okay. 42, 4D, 46, 0, 0, 0, 0, 0, 0, 0, 36, 0, 0, 0. Finally, God. Okay, this is correct. Next. Hate my life. Oh, I'm too tired to do next. How long have I been streaming for? God, it's been 2 hours and I didn't even get any pixels on an image. I didn't even start rasterizing. Okay, I need to finish this. I need to finish this stream. Otherwise, I'm gonna feel bad. Do this. Do that. Do this. Planes, pixels, compression. Planes, pixels, compression. Just controls it. What am I doing? Dip. Get the dip. Hey bro, do you want the dip? I'm losing it, guys. This is me losing it right now. I am losing it. Why would you? Oh, no, it was correct. It was correct. I'm just stupid. It's fine, it's fine, it's fine. Don't worry about it, don't worry about it. It's all good. It's all good in the hood. Do you know the hood? You know the hood? It's good in the hood. The hood is good. Okay. Alright. Okay. Size of this. 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 Do you know the hood, bro? I know the hood, bro. The hood is good, bro. I know, bro. Thanks, bro. I hate the word bro, by the way. Okay. Will you continue the series? I need to finish this rasterizer. I thought I'll just do it in one sitting. Alright, let's see. 42 4D 46000 0000 36000 28000. Those are 3 zeros. 28000 02000 02000 0100 1800 0000 10000 13 0B00 13 0B 1300 000. Oh my god, it actually fucking works so far. I said fucking, I'm not supposed to do that. I need to stop. But it works. It's correct so far. I just did the final things are the pixels. That's the data. The final thing is just the data. Oh, kill me. Please, just do it. Okay. Next. God. R. G. B. G. B. How many RGBs were there? Yeah, just two. And then this is for number 1. Oh no. Do this. G and B. Copy these. Okay. And then the padding, obviously. Padding 1. There should not be padding 1, padding 2. It should just be padding 16. Padding. B. Dot padding. Size of padding. Copy this. Paste it one more time. Instead, we do 1s over here. Nope, not 2s. 1s. 1s, my friend. 1. Okay. 1, 2 padding. 1, 2 padding. And that's it. I swear to God, if I don't see pixels on the screen, someone is gonna die. Sorry. Guys, look! Fucking pixels! Holy shit. Holy shit. Look at the... Why are they black? Oh, no. Wait, what? What? Okay, that's weird. Where are... Can you... Thank you. This is weird. Okay, I don't know. Oh, this is me having... Okay, cool. Guys, look. I don't know if the magnifier works on YouTube. It doesn't. I don't think it works on YouTube. And I cannot zoom any further. Okay, we're just gonna go to Photoshop because Photoshop makes you. Oh, Captain America! Is that Captain America? No, America woman America something. Miss America. Is that Miss America? I don't know. Maybe she's someone else. I don't care about you. Okay, zoom in. Guys, look, pixels! Look at those pixels! Beautiful. Is it? Are they correct? I don't even remember. I said the first one would be red. It goes right to left. Red, then what? Red and then blue. Red, blue. White. Wait, this is green. I'm stupid. Red, green. Red, green. Oh, red, green. Red, green. White, blue. Why is it going vertically? Why is it going vertically? What? It does it vertically? What kind of stupid system is that? Wait. It does it vertically. He did red. Wait, no. Red to white. Blue, green. It goes from bottom to top. Oh, it goes from bottom to top. Why does it go from bottom to top? That is so dumb. That is so dumb. Why does it go from bottom to top? Oh, that is dumb. Oh, that is so dumb. Left, right. It goes left, right, bottom, top. I was expecting it to go left, right, top, bottom. And I set my data that way. But it's not. So red, green, red, green. Okay. I did not expect my data to look that way. So, wait. Maybe I'm writing my data wrong. Oh no. Row of pixels. The first row I'm saying 0, 1. Oh, I mean, no, this doesn't really matter. I mean, these really don't matter whatsoever. But, you know, let's fix them. Yeah, these don't matter whatsoever. Red, green. How would I fix this? How do I lay out my data correctly? This is pixel data, row of pixels. This is no longer correct. So I write my first pixel, then I write my second pixel, and then I do the padding. Why is it wrong? What? There's something wrong. Hold on. What? Where's the value of this? 255, 0, 0, 0, 255, 0. And then the padding. Why am I getting columns? I'm confused. What? I'm writing red. Look, I'm writing red and then I'm writing green. Red, green. Why is it red, green? For him, it's different. What? Red, white. Why is it going right? Why is it completely different for me? Will you do that point showing 3D object or just rendering triangles? For now, I'm gonna start simple by just rendering triangles. I am so confused. 0, 0. Let me use the same as let me use same colors as he is. So he's doing 0, 0, 255, 255, 255, and then 255, 0, 0, and then 0, 255, and 0. Let's try that. Should be exactly like his image. Okay. Blue, green, red, white. What? What? I am so confused. Is it not laid out as RGB? What's the file format? RG... Red, green, blue. Red, green, blue. RGB. Red pixel. Oh my god, it's backwards. Okay. It's 00 to 55 for red. It's GBR. This is dumb. It's BGR. Oh god, please give me patience. Wait, but that doesn't make sense. I did the same thing. What? No, hold on. Oh yeah, it's BGR. It's BGR file format. So when I write this, I write blue first, then G, then R. It's BGR. This is kind of stupid. This is not kind of stupid, it's very stupid actually. Stop, I don't want, go away. Okay. So I wrote blue, white, and then red and green. Yeah, there you go. If I want to do green, blue, green, blue, and then I'm gonna do R, G, B. No, I'm gonna do red, green, and then white. So I expect to have something, whatever the thing is. I expect to have it. Okay. Okay. So red, green, blue, white. Red, green, blue, white. And if I go back to his example, it was... So he wrote red, white. Okay, red, white, blue. Red, white, blue, and then red, white, blue, green. Red, white, blue, green. Okay, I should get the same image. In theory, the same image. Blue, green, red, white, yep. Where, same image, where I do red and then white, bottom left. Okay, it matches. God, okay. Dude, I have pixels. Oh, that's all I want. I want some pixels on the screen. And I have it. Oh, this is such a messy code. Need to go clean it up. I think I'm gonna end here. I thought this was gonna be much easier, much simpler. Holy moly, I'm tired. I'm extremely tired, extremely hungry. All right, I'll end it here. Jesus. Cool. All right, see you guys. I'll do the SFML stuff later. I don't know when I'm gonna stream, honestly. Look, to be honest with you, I just need to get my shit together. I have a few issues that I need to solve. They're keeping me up at night, and I cannot really focus. So let me just sort that out. It'll take like a week, I think, hopefully. Once that is sorted, I'm free to stream SFM and stuff. Anyways, thanks for watching. I hope you enjoyed seeing me suffer. I'll see you guys later. Sayonara.